Okay, gang, so we had just gone through that heroic process of finding the area by using rectangles. And again, you're just taking a little basic toe step into using rectangles and iterations. I did an entire 16-week class in graduate school about doing stuff like this. I mean, it's really can get very extensive if it's something that you like. Iterations can be used in a lot of areas, and this may be something you really enjoy. So something like a course in regression analysis may very much interest you. All right, but we are just taking our toe. We just put our toe into this concept so you can see it. It does have uses. Like if it's hard to approximate something, or sorry, if it's hard to find the value for something, then we can approximate it. We can get really close by iterations. And as you can see, if we let the iterations go to infinity, we can pretty much get it if there's an answer to be gotten. So the reason why I'm saying all this is because this next thing I'm going to show you, if we were in the classroom, I would usually get a bunch of haters. So I'm preferencing that, saying that yes, this technique is very useful, and yes, this technique is sometimes the only thing that can be used to find a solution to something. All right, so I don't want you to like throw this out, what I just did. If we were in the classroom, I would structure the way I'm doing this very differently, but since we're online and doing these videos, I just want to show you something right here and now, which I would never do in the classroom because, like I said, the haters would come out enormously. But you have to remember that this technique is sometimes the only technique that can solve certain problems in the math world, okay? Regression analysis. All right, so we haven't actually covered this yet. It's in the next section coming up, but I want to just show you something really quick. There's something called the fundamental theorem of calculus, also combined with a concept of how you find the area between two curves. It's the top curve minus the lower curve. So I am mixing a couple things here that I haven't taught you, and this will make a little more sense when you do the next lecture, but I just want to leave this here for you to think about. So one of the applications of integration is finding area, and I'm going to show you that right now. So again, it's more complicated than what I'm doing here, but basically it's the top function minus the lower function. The lower function here is 0, which is why you won't see me writing it. The top function is x squared, and then I have to write on what x values I'm going to. So I started at 0 and I went to 1. So these are what we would call the limits, and we're integrating in respect to x. Okay, so the haters are about to come out. Be ready for them. So you guys learned how to integrate in 5.1. So to integrate this, it would be x to the third over 3. With a definite integral, which this is, if it has limits, you don't write plus c. You don't do it if it has definite integral. You put a line here and you say, I'm going from 0 to 1. And now you plug in, it's the upper limit. And again, you're going to learn this in the next section. But now, this is the fundamental theorem of calculus. I've integrated, now I'm going to plug in my limits. So it's 1, you plug in the top one first, then you subtract the bottom one. So this is 1/3 minus 0, which is 1/3. Okay, do you know what I just found in 2 seconds? I could have done this really fast. I was trying to explain it as I did it, right? I just integrated and evaluated. That, my friends, in 2 seconds is also that, okay? And don't be a hater. Don't be a hater. This has its own use, okay? But when you see me going over the fundamental theorem of calculus coming up, it's a really powerful tool if we can find the area very fast. Okay, gang, that's it on this section. Catch you. Bye-bye.